Yes.
Okay. Now today we're going to start similar triangles. They're actually not that hard until it clicks. Once it clicks, you're going to be like, oh, dude, this is easy. It may be slightly confusing at the beginning, but just hang with me. Are you with me? Okay. All right. Let me give you the definition first. Two triangles are similar if they have two angles in common. So there's the definition. Two triangles will be considered similar if they have two angles that are the same. In common, let's put two angles the same. So, let's talk about that for a minute. Now, they can be different sizes. I can have a big one and a little one, but we're looking at the angles. Thank you, Perla. So let's say they give me two triangles, a big one and a little one, and the question is, are they similar? So we need some angles in here to see. Let me erase that. Let's not do 90. Let's do 90 over here. Okay, first of all, how could I tell if they have two angles that are the same? So, what do you think?
The first, you just add up the two numbers that you have and then subtract it by 180.
Okay, so you want to try to find this angle here? That's a great idea. Y'all agree?
Yes.
So, what's 48 plus 52? Calculator, people. 100. How much is going to be in that angle? 80, because if we do 180 minus 100, there's 80 left over for this angle right here. All right? Don't they already have one number that's the same?
Yes.
Do they have two numbers that are the same?
No.
No, they do not. Doesn't this one have an 80? Does this one have an 80?
No.
No. So is this angle going to be the same as that angle?
No.
No. But let's go ahead and find it just to make sure. What's 90 plus 48?
135.
Oh, I heard
138.
you sounded pretty confident. I like that. 138. Couldn't we subtract 180 minus 138?
Yes.
What do we get?
42.
42. So do they have two angles that are the same?
No.
No. We got one angle that's the same. They got to have two angles that are the same to be similar. This is not similar triangles. Question so far. If I can find two angles that are the same, we can say they are similar. Yes?
If it was 48, or like if there's like flipped.
They can be in different spots. Is that what you're asking? Good. Yeah. You're about to see that. Let's do another problem and see if they are similar. Let's do... And let's see if these two triangles are similar. What do y'all want to do on the first triangle? Gabby?
83 plus 51.
All right, what is 83 plus 51?
134.
You sure? Okay. You sounded pretty confident. He's got a calculator in his hand. I'm going to trust him. Let's subtract 180 minus 134. What is this last angle?
46.
46. All right. Oh, dang it. Can I change this? I'm sorry. There were too many numbers going in my head when I made up this problem. All right. Can we say if they are similar right now?
Yes.
We can? Are they similar?
Yes.
How do we know? Prove it.
Well, they're not right now. There's one angle that's similar.
You sure? Paul looks confused.
Oh, wait, yes.
You
yes,
say
there's
something
two.
different, Paul?
Yeah, there's a 46 on one and there's also an 83 on both of them.
Okay, don't both of them have a 46?
Yes.
Don't both of them have an 83?
Yes.
If we find two angles in both of them that are the same, we can automatically say they are similar. So this one is similar, and here's why. What's this last angle right here? How much? 51. By the way, if they're similar, all three angles are the same. Are you with it?
Yes.
But you really only need two of them to say they are the same. If you can find two that are the same, 46, 46, 83, 83, if two of them are the same, then the third angle will have to be the same as well. Does that make sense? Okay. Because all of them add up to 180. So the baseline is we got to have two angles that are exactly the same. Questions? All right. So we can tell if triangles are similar by that simple definition right there. Now today they're also going to ask us if we already have two similar triangles. We can do a little math with it. Let's go with 6, 10, and 40. So, let's say I drew this picture here. I've got a big triangle, and inside the big triangle there's another little triangle. Are you with me? And they might ask you to find, like, the distance from here to here. Let's call that X. So, they're going to tell you these two triangles are similar. Here's how we know. I can prove it real quick. Don't they both have a 90 in the corner?
Yes.
So there's one angle that's the same. Are you with me? And isn't the big triangle have the same angle as the little triangle in the corner, the left corner? So don't they both have the little angle here the same?
Yes.
And they both have a 90. Are you with it? So we can prove real quick that they are similar, but they already told us they were similar. So if they are similar, that means they create a proportion. One of them is just a little bit bigger than the other one, but it's in the same ratio. So watch this. Anytime we have a proportion, we can automatically create a fraction equal to another fraction. So, do you see my numbers? I got 6 here, 10 here. I don't know the big bottom, but I do know the height of the big triangle. So, I always take the one that I have two numbers in. So I'm going to call this the little triangle. Let's put the little numbers over here. All right. So which one do y'all want to put on top? It doesn't matter really. You want 6 on top, all right? So I am going to label that. We'll put the big numbers over here. That is the bottom. So I'm going to label that the bottom of the little. What is this? What do y'all want to call that?
The middle. X.
Not the middle. We're talking about the little triangle.
Oh.
What do y'all want to call it? You can call it the right side, you can call it the height, you can call it whatever, but yeah, let's call it the height. I like the height better. No looking forward with the height. So let's call the height 10. Are you with it? All right, so what do they give me in the big triangle? Do they give me the height or the bottom?
The height.
They give me the height. So where do I need to put the 10? On top or on the bottom?
Bottom.
Where do we put the height? We put it on the bottom. You better put 40 on the bottom. What do we not know?
The X.
What is that?
Bottom.
The bottom. We do not know the bottom of the big triangle. Are y'all with it? Okay, so let's put X right here. Tell me how to solve a proportion. I forgot. My mind went blank. Zach.
Wouldn't it be 6 times 4?
No. Oh, we'll get there. Tell me how to solve this proportion. Yes, keep that thought for a minute away. Not yet. Yes.
I think that you can do like 40 times 6.
Yeah, we do the butterfly method.
Yeah.
So, multiply the top here times the bottom there. What's 6 times 40? Calculate it, people.
240.
240. And that's equal to this times this. What's 10 times x?
20.
What's 10 times x?
Next.
10x. And how do I solve this equation? What do I need to get rid of, Isaiah?
The 10?
Good. We're trying to get x by itself, so how do I get rid of it?
Divide by 10.
Divide by 10. And when we divide by 10, you're going to hear a number that Zach said just a minute ago. What is the answer? 24. So the bottom of the big triangle is 24 feet, inches, whatever they label it on the assignment. All right, now Zach, would you like to share what your brain was thinking earlier?
So 10 times 4 is 40, and 6 times 4 is 24.
Good. Did y'all follow that?
Yes.
Let's go over it in case you missed it. Zach goes, hang on. 10 times 4 gives me the big number. Are you with me? 6 times 4 has to give me this number. Are you with it? So, what Zach's brain did is he found the common ratio. Remember when we did proportions, you had to find K. Remember K, the common ratio? Remember all that good stuff? It's been a few weeks. But that's what Zach's brain did. He's like, 10 times 4 is 40. 6 times 4 gives me that answer. And he is correct. Questions? All right, yes.
I did proportion.
40 divided by 10?
No,
Oh, okay.
I did 40 times 6 divided by 10 and got 20.
That's what we just did, sweetie.
Well, no,
40
no,
times 6 divided by 10. You did exactly what I did.
Yeah, but no, the crossing out.
You need the proportion because sometimes you might do the 40 times the 10. You got to be careful.
Yeah.
All right, moving on. Let's do another one. What if I tell you these two triangles are similar? And let's do, angles this time. No, angles are too easy. Let's see if Zach's brain's working now. All right, can we do this one in our head? I'll give Zach a shot to see if he can give me the answer real quick. Yes, no? Oh, he's going to the calculator. Doesn't count. Doesn't count. Stop. All right, you got it?
Would it be 28?
Try again. All right, let's set up our proportion. So, let's call bottom, right side. Y'all agree? Mm-hmm. Okay. So, what do y'all want on the top?
12.
The 12, that would be the right side. And we'll put the bottom on the bottom. That makes sense. So let's go 12 over 16. And what are we going to put over here?
X over.
X over 24. Sweet. Let's do our butterfly. What's 12 times 24?
288.
288. What's 16 times X?
16x.
16x. And what do we need to do? Divide by what? 16. And what do we get?
18.
18 is the X value. So some of them you'll be able to do in your head. I made the scale factor here 1.5. and it tripped up Zach because it wasn't an easy number. You had to multiply it by 1.5. 1.5 of 12 is 18. 1.5 times 16 is 24. So sometimes you can just look at them and do what Zach did. Ooh, 24. Sweet, that's good. Put it. Sometimes you're like, I can't do this one in my head. Do the proportion and it'll tell you. Questions? All right, we're ready to roll.